Hey guys, this is your teacher again. Welcome to pre-calculus. Alright, so let's pick up where we left off from last time. Last time we concluded with example 4, so this time we're going to pick up example 5. Alright, example 5, given the function f of x equals 2x squared plus 3 and another function g of x equals 3x to the third plus 1. So this is really giving the functions because I'm giving you two functions. Okay. I want you to find A, B, C, and D. And can you add this for me and state the domain of each? Okay, so after we have found each answer, I want you to find also the domain of the answer. So here we go. This is f plus g of x. Okay, this is equivalent to, okay, just taking two functions and adding it together. Okay, it's just that easy. So if I'm going to take f of x, which is 2x to the third, 2x to the second plus 3, I'm going to write that down. 2x to the second plus 3, 2x to the second plus 3. I'm going to add, okay, g of x, which is 3x to the third plus 1, 3x to the third plus 1. Because I'm just going to add these, I'm just going to try to find common terms, okay? 3x to the third does not have any common terms, so I'm going to write it from highest power to lowest power, or in descending order. So 3x to the third is my first term. 2x squared does not have any other term, so we are going to write that next. I can add a 3 and a 1, so that will give me a result of a 4. So this equals to f plus g of x when I combine those. Okay, so that gives me that answer. Now I want to find the domain of this. Now this is a cubic function. Okay, so 3x to the third plus 2x squared plus 4 is a cubic function. So if you look at this, whatever input I put in, okay, any cubic function, that's going to be a function. Okay, I'm sorry, what am I saying? I'm repeating myself. Any cubic function, the domain is going to be all reals. And let me just give you a picture of it, a graph, okay, using my calculator. Oops, my calculator says low battery. All right, so hopefully it's not going to die in the middle of this. So we're going to put in 3x to the third. So I'm going to hit y equals 3x to the third, okay, plus 2x squared plus 4. I'm going to see if I can adjust my window, okay, from negative 10 to 10. And I'm going to hit graph. So this is what it looks like to be a cubic function. Okay, so this particular, notice how it looks like a lazy ass here? This is if I make it really large, okay, like I zoom totally out. So look at my window. My y minimum is in thousands, okay, and so is my y max. So what is it going to look like if I minimize my window a little bit less? How about negative 100 to positive 100? Okay, so notice how I can see a little bit better. Okay, I'm gonna minimize it some more. Okay, so I'm gonna minimize my window again. So let's go negative 50 to positive 50. All right, looking better. Okay, let's minimize them more. Let's try from negative 10 to positive 10. Okay, I want to give you a kind of visual what it looks like if I zoom out. Okay, now this is if I really zoom in from negative 10 to the x, positive 10 on the x, negative 10 on the y, positive 10 on the y. And it looks like that. When we had it such a large window, notice how like it looked like it was kind of crossing over the origin, which is right in the middle. But when you zoom in, it doesn't really cross over the middle. So from the graph, as you can tell, that this is a function, okay? Because look, it passes my vertical line test, okay? Now how would I do it if I didn't have my graphing calculator? Then you would just pick some values. For example, let x be 0. When x is 0, this is gone because 0 times anything is 0. This is gone, and now I would only have the output, which is y equals 4. So one input, I have a unique output. How about when x is 1? Okay, I'm just kind of testing out some inputs here to see how many outputs I'm really going to end up with. So when x is 1, 1 to the third is 3. I'm sorry, what am I saying? 1 to the third is 1. 1 times 3 is 3. So output is 3 plus 1 squares 1 times 2 is 2 plus 4. So my output is now 3 plus 2 is 5. 5 plus 4 is 9. One input, unique output. There isn't two outputs popping out. So again, the domain, this is a function, okay? And the domain, if you can tell, is going to be all reals from negative infinity all the way to positive infinity. So domain, okay? You can write all real numbers, which is the R, or you can write interval notation. Remember how we were writing interval notation? Interval notation is going to be negative infinity to positive infinity, okay? And yes, you need to write down the domain of this piece. All right, now let me make a line here so I can be nice and neat. I'm always sort of invading like the other parts. Let's try. I'm going to try my best to kind of keep my examples in its own space, okay? Okay, B, I want you to find f minus g of x and then state the domain of it. So this is equivalent to f of x minus g of x. Okay, so that's what it's equivalent to. So I'm going to take the f of x, in this case 2x squared plus 3. I am going to subtract g of x, but because I'm subtracting a binomial, I am going to put parentheses around the entire function. All right. I don't want, if you don't put parentheses around this whole piece, you're going to get the wrong answer. So make sure you put parentheses around the entire function. So for the next piece I'm going to do is I'm going to distribute this negative sign. Negative times a positive is a negative 3x to the third. A negative times a positive 1 is a minus 1. And then similarly, now that they're outside of their parentheses, I'm going to combine like terms. If there are terms that I can't combine, I'm going to write it in descending order, highest power first. So this one is the highest power, which I can't combine. So I have negative 3x to the third and a positive 2x squared. Those two terms I cannot combine. But I am going to combine the 3 and a minus 1. I'm going to end up with a positive 2. So this is what, I'm not going to write it over here. I'm going to write this is what f minus g of x comes out to. I'm trying to keep like this in this space, okay? So what I want to do is, hey, what is the domain, okay? So now that we have this, let's go back to example 4, how you find your domain before. So start with the domain as the set of all real numbers. Remember this in the bottom here? Okay. This has a denominator. This does not have a denominator. This has a radical. So start any equation you have. Start with, according to this, start with a set of all real numbers. Then you would exclude if you have a denominator. Okay, and you would exclude if you have a radical. Remember, so over here we excluded some values. Over here we excluded some values, but not here. So let's look at our final answer. This doesn't have a radical. It doesn't have a radical. So we're not going to exclude anything there. Does it have a denominator? It doesn't have a denominator. So guess what your domain is? Domain, your domain, it's all real numbers. Okay? Or I'm going to write it as interval notation because we're going to get to use interval notation very soon. So let's get used to it. And that's what I'm going to write. You would only need to exclude if you have a radical or a fraction, which is a denominator. Okay? Again, if we are going too fast, why don't you hit pause for me and then finish writing and then continue again so you're not lost. All right, let's take a little break and let me tell you a little joke, okay? What do planets like to read? What do planets like to read? Comet books. Get it? Comet books. Welcome again. I have a lot of toddler jokes, so hopefully you enjoy that one. All right, let's pick up with C. On C, we are doing multiplication, okay? And again, f times g of x is the same thing as f of x times g of x, okay? And again, I'm going to try to keep it within that line. Okay, let's draw that right now. So I have f of x, which is 2x to the third. So I'm going to write that down, 2x. I'm sorry, I keep saying 2x to the third, but I meant to say 2x squared. Positive 3, so plus 3. I'm going to do multiplication, so I'm going to write another parentheses, and I'm going to multiply that with 3x to the third plus 1. So here we go. Okay. And now I can distribute this, or FOIL it. It's what some of you call. So I have 2x squared times 3x to the third. By FOILing, I have 6. 2 times 3 is 6. X squared times x to the third. When you multiply, you add your exponents. That's 6x to the fifth. Then I'm going to take this and multiply to 1. Anything multiplied to 1, it's itself, so 2x squared. Then I'm going to take these middle, okay? 3 times 3x to the third. 3 times 3 is 9. X to the third is just going to be x to the third. Okay? Then 3 times 1 is going to be 3. I'm going to write it in descending order. That means I'm going to write it from largest exponent to smallest, or 0 or no exponents at all. So my largest exponent is going to be 6, x to the fifth. My next higher exponent is going to be 9, x to the third. The next exponent is 2x squared, and bring down my 3. And this is my final answer to f times g of x, and I'm going to box that up. Okay. Now I'm going to have to find the domain. Okay, so the domain, let's start with, do we need to find the exclusions? Okay, does it have a fraction? That means, does it have a denominator? So does it have a denominator for this final answer right here? It has 4 terms, it has power 5. None of that really matter because it doesn't have a denominator. Okay, does it have a radical? So does it have a radical? It doesn't have a radical. So your domain is going to be all real numbers. You are right. It's that easy. Okay, or again, we're going to write it as interval notation, from negative infinity, from one side of x axis to all the way to the other side. Okay, so that means it includes every single number you can think of. So it's also called all reals. All reals is the same as negative infinity to positive infinity. All right, now we have D, which is a division problem. Okay, so in this division problem, this is going to be equivalent to f of x divided by g of x. Okay, so that's what it equivalents to. So let's check it out. Here we go. F of x is 2x to the third, so we're going to write 2. I keep saying 2x to the third. What is wrong with me? 2x squared, I meant, plus 3 divided by g of x is 3x to the third plus 1. Okay. Well, can I factor out anything from the numerator? Do they have anything in common? Nope, you can't factor anything. Can I factor out anything from the denominator? Nope, they only have 1 in common, so I really don't need to pull out anything. So guess what? I can't reduce, so this is my final answer. Isn't that the easiest thing ever? Okay. That's my final answer. Now, because that was easy, let's try to find the domain. Okay. Domain. What is the domain of this? Can I just put down all real numbers? No, you cannot put down all real numbers because what does it have? It has a denominator. And because of in a fraction with a denominator, this can never, ever, ever be 0. Okay? So you're going to have to find the values of x. Okay? What values of x can we plug in here? Okay? That will make it 0. So we can exclude it from the domain. Okay? So what we're going to do is we're going to take the denominator, which is 3x to the third plus 1. We are going to try to find x. Okay? What x values will make it 0? So that way I can get rid of it from my denominator. So I'm going to subtract 1 from both sides. I now have 3x to the third equals negative 1. Divide both sides by 3. X to the third equals negative 1/3. Okay? Now I'm going to take the third root. Okay? Because I am going to take the third root, I need to put 3 index right there, because it's not the same as the square root. And so x to the third, taking third root, I do have an x. Okay. Now I can separate these, so I'm going to end up with a negative 1 to the third power divided by 3 inside to taking the third root. Okay, so I'm taking the third index here. So that means this little 3 goes in the little v or caret, whatever you want to call this. Negative 1, taking the third root, it's going to give me negative 1. Yes, you can actually take a radical, a negative radical of a third root or fifth root or seventh root. If it's a square right here, okay, a power of 2 or square root we call it, or fourth or sixth. So with an even index, these numbers are called index, then you may not have negative here. So third root of a negative 1 is negative 1 over. I'm going to right now show you how I would simplify this. I'm going to multiply, which a red pen. I need 3. Okay, so let's talk about third root of 3. For me to pull this out, for me to rationalize this, I need 3 3's. Okay, I need 3 3's to pull it out the radical. Currently, I only have 1 3. So I'm going to go in and multiply the third root of 2 more 3's. So 3 times 3, or you can even do with just a 9. What I multiply to the bottom, I'm going to need to multiply to the top. Okay, I'm kind of running out of space. I'm hoping I can just squeeze this. So now, notice how on the bottom, I have third index, they're both exactly the same index, of 1, 2, and 3. Therefore, I now can pull one of those 3's out, okay, which I'm going to write with a pen. Okay, you guys see that right there? Then, on the numerator, I now have a third root of 3 times 3, which is 9, which I cannot reduce or simplify. So I'm going to multiply that with a third root of 9 right here, which I'm hoping you guys can all see that. Okay. So my final answer, just to make it prettier, I'm just going to write it over here, because this is the only spot that has space. Okay. So x, when we set that out, we said x is going to come out to be negative third root of 9 all over 3. Okay. But remember, this is the value of that x that makes my denominator equal to 0, which I'm going to need to exclude that from my domain. Isn't that crazy? So the domain is all real numbers, not including, or I'm going to write x cannot be. So notice how I wrote set anything it wants to be except, I'm excluding, negative third root of 9 all over 3. Okay, and I would need a bracket over there. Sorry, I'm trying to really squeeze in that wavy bracket. Okay, so make sure you write the answer, and then this index has to go in that little pocket or the little caret thing. Okay, so the domain is all real numbers. Okay, or you can just say all real numbers except negative third root of 9 divided by 3. Or you can write x cannot be this particular value, which is negative third root of 9 over 3. And that is my final answer. Woo, woo. All right. So Since this is the last example in our 2.1 notes, I'm going to stop right here. Okay, but before I stop, I'm going to read you the summary of how to find important facts about your functions. Okay? All right. So, facts. Important facts about your functions. For each x in the domain of f, which is whatever function I'm going to give you, there is exactly one image, f of x, in the range. That means for each x you put in, you should get one y. Okay? F of x is similar of y in the range. However, an element in the range can result from more than one x in the domain. That means you can have two x's for one y, but you can't have two y's for one x. Okay? So let's talk about boyfriend or girlfriend. Let's give x as a girlfriend and y as a boyfriend. Okay? So for one girlfriend, one x, you can only have one y. Did you get it so far? That's the definition of a function. Now, but one y, one boyfriend, can have two different x values. Okay? So think about this as old school back in the days where men could marry two different women. Okay? So that's still a function. So think of it as still functioning in some families today. Okay? B. F is the symbol that we use to denote the function. So if you see f right away, or f of x, or g of x, you know right away it's a function. It is symbolic of the equation that we use to get from an x in the domain to f of x in the range. Okay? So f of x is a function, g of x is a function, so those are the functions with the x as a domain. If y equals f of x, then x is called the independent variable, or argument of f, and y is called the dependent variable of the value of f at of f at x. Okay, so y is the output and x is your input. All right, so those are some important stuff about functions, and 2.1 is all about a function. And then 2.2, we're going to graph a few more of those functions. This is the end of our video notes. Have a good day, and I'll see you next time.